All right, today we are going to start learning about optimization, which means like how do you make something biggest or the smallest or something like that. The idea that you probably want to be familiar with is that first derivative test. So say I have some equation of blah, 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 all right? And I take the derivative of that. And so the derivative is equal to yada, 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 yada. Now, what I'm going to do is I'm going to set that equal to 0, and I'm going to get some critical numbers coming off of this. Like critical numbers like x is equal to 1 and 2 and 3 or something like that. All right, and so if I put that on doing the first derivative test, and I have values like 1 and 2 and 3, and I take this and I take a look at how the first derivative acts to it, and we'll say that's positive, positive, negative, positive, or something like that. What is this saying? What's happening at 1? Well, nothing. It does something like this. It like kind of hiccups or something. Okay, but it's not a max, it's not a min, anything like that. All right, so what's happening at 1? Nothing. What's happening at 2? Well, positive goes to negative, increasing goes to decreasing. So that's a max. And then at 3, a decreasing goes to an increasing. So that is going to be a min. Now, the thing to keep in mind is that this is a max or a min of the original equation. So if this original equation is, like area, well, you just maximize or minimize the area at those particular x values. All right, so you can tell information, and it doesn't have to be just some rando f of x. It could be area, it could be perimeter, it could be the sum of product or something like that. So you can maximize and minimize anything that you can make a formula to, pretty much. All right. So they begin us off with these rando questions about you got 2 positive numbers and they do something. All right. And so this first one is probably the weirdest one, but it'll work out. Okay. 2 positive numbers that satisfy the given requirement. The sum and the product is a maximum. The sum and the product is a maximum. Okay, the sum is s, the sum is s and the product is a maximum. So the sum, that means an addition, is s. And then the product is x times y. Okay, the sum is s and the product is going to be a maximum. All right, so what I'm going to do with this first equation, the sum, is I am going to kind of eliminate one of the variables. I'm going to write, y inversion of an x or something. So y, for instance, is s minus x. And then what I'm going to do is I'm going to substitute that into that second equation. So the product is equal to x times y, which is now s minus x, or aka negative x squared plus sx. All right. Now I'm going to take a derivative of this product with respect to x. So the derivative of the product with respect to x is negative 2x plus s. All right. So what I'm going to do is I'm going to find any critical numbers. Where is this thing equal to 0? And so if I do that, I subtract s, divide by negative 2, that'd be 1/2 s. So something important is happening at 1/2 s. That's a critical number. Something important is happening at 1/2 s. Let's see what that important piece is saying. So this with the derivative at 1/2 s, again, 0. Let's say I put in a small number, like something less than 1/2 s, right? 1/4 s or something like that. So into the derivative, if I do something. Actually, no, let's go big. Let's go big. Like put in a really big number, like, 20 or something like that, and 20s. And so what's going to happen is if I put in 20, that'll be a majorly negative number, and so this is going to be a negative. And if I put in a really small s, okay, this is going to be positive. All right, so what is that saying? That there is a maximum at that 1/2 s. So the product is maximized. Cool. Okay, the product is maximized, which is exactly what we are looking for. Okay, where is the product maximized? It's when x is equal to 1/2 s. Now, what is y then? Well, if x is 1/2 s, I go back to this equation right here. And if that's 1/2 s, I subtract that. Y is also 1/2 s. And so that would be the sum is s and maximize the product. Again, you usually don't work with this many letters. Like, I think this is the only weird one. Everything else actually deals with numbers and stuff like that. All right, let's take a look at the second one. The product is 147. So x times y is 147. The sum of the first number plus 3 times the second number is a minimum. So s is going to be a minimum. Okay, let's solve for one of these things. So let's go x, for instance. X is equal to 147 divided by y. Okay, so we have an s. Now let's take the derivative of that and let's see let's see if we can actually get some numbers out of this thing. So the bottom goes up. Derivative of the top is what, 6y. Minus, leave the top alone. Derivative of the bottom is 1. All of the bottom squared. Okay, critical numbers. Critical numbers would be when y is 0, that would make it undefined, and when this numerator is equal to 0. So when 3y squared minus 147 is equal to 0. So y squared is equal to 147 divided by 3, 49, and then thus y would be equal to plus or minus 7. But because they're both very specifically positive numbers, it says it, that would imply that y is equal to 7. All right, so doing the first derivative test, I have y and I have the sum. And we are testing out the numbers 7 and 0, I guess, but obvious. So testing a small number like the number 1 into the derivative. So that's 3y squared minus 147 divided by y squared. So that's going to be a negative number. Then anything bigger than 7, like such as like the number 8 or something, is positive. So that implies that this is a minimum, decreasing to an increase. That is a minimum, which again, we want the sum to be a minimum, and so the sum is a minimum when y is equal to 7. So if y is equal to 7, that implies that x is equal to 21. The sum of the first number and twice the second is 108. The product is a maximum. So that product is a maximum, which is I want it to be that. So y is equal to 27, and then x is 54. Okay, so we're talking about a what, rectangle? So a rectangle, so I'll call this x and y. So its perimeter is 80 meters. So that's 2x plus 2y is equal to 80. So the distance around is 80. We want to maximize the area. So the area is x times y. So let's go with 2y is equal to 80 minus 2x. Y is equal to 40 minus x. So the area is equal to x, 40 minus x. So area is equal to negative x squared plus 40x. The derivative of that with respect to x is negative 2x plus 40. I want to know where the heck that is equal to 0. So negative 40 divided by negative 2. 1. Let's test that out. And so testing a small number, I see that it's going to be a positive. Big number is going to be a negative. That implies that this is a maximum right here, a maximum area, which we're looking to do. So we're maximizing the area. So x in this specific case is 20. so is y. Oh, and the maximum area, sorry. You need to answer that as well. These are the dimensions, and thus the maximum area is 400. Meters. So meters, meters, meters squared. All right, so the rectangle has an area of 49. And we want a minimum perimeter. So perimeter is 2x plus 2y. Sorry, bottoms up. Just breaking my own rule. Bottoms up. Derivative of the top. Come on. Falling apart here. Derivative of the bottom is 1. All right, where does this stuff equal to 0? So 0, and then wherever 2x squared minus 98 is equal to 0. So that's 98 divided by 2 square root, so that's plus and minus 7. Again, negative doesn't make any sense. X is equal to 7. Let's just make sure that this is, I think, a minimum. I think we're looking to minimize the perimeter. So we want this to be a minimum. That is indeed a minimum. So the x is 7, the y is 7, and the perimeter would be, what is b? Thus the perimeter would be 2x plus 2y, 14 plus 28. That's still feet. That's what the perimeter is. That's it.